Well, good morning. This is the part 2 from our 4-part series of the robots and marbles. We're walking through the examples that we have online in our GitHub repo. We're going to do the template version where we walk through exactly how BlockScience approaches these problems and some recommendations for how you can as well. And we're slowly building. Last time we showed the basics of how to run cadCAD. And this week, we're going to be adding some policies on top. What do policies and behaviors mean? And showing how we're going to be gradually increasing the complexity of the same robots and marbles. So to refresh your memories, what we did last week was we had the first step, which was defining basically what are we doing. When we're modeling something, we were going to whiteboard. In this case, I lucid chart because it's easier to show on a computer, and it looks better. My handwriting's really bad. So what we have here is we have a robot, and there's some process, and then there's going to be moving marbles between 2 different boxes. Well, ideally, what we're trying to do is have an equilibrium of the same amount of marbles in each box when we start with 10 marbles. And this robot is going to be picking up the marbles and moving them to different boxes. Then after we do that, we go to our mechanism states, which is this way that we've created a swim lane approach where we have behaviors, mechanisms, and states. Last week, we only talked about the mechanisms and states, where we had a mechanism that updates based on what happened in the last state. Say initially you could say box A had 10 marbles, box B had 0 marbles. So after each time step, the model would say, okay, the arms would say, okay, well, there's 9 in this box, there's 1 in this one, so we need to try and fix that. So then it would update. We had a policy here. Remember, we wrote out some mathematics that we sometimes include. I'm not including them for this example as the third step to kind of define in more concrete manner what kind of process we're doing here. So this week, what we're doing is we're adding something called a policy or behavior. It's the behavior of the robot. So essentially we're having the robot here, and then it now has its arms, and then it has the state. So this seems like a very insignificant point in this example. But when you start talking about doing ecosystem modeling and things like that, you'll have various actors or cohorts of groups. Say you could have a bunch of investors. You could have different classes of investors. You can have people that hold on, people that are speculative, and you'd have different behaviors from them, and you'd build in these behaviors, and then that would update like based on external market data or something like that. Should they sell more of this currency? Should they buy more of it? Things of that nature. You can start modeling these users or these groups of users in agent-based modeling type approach. So in this example, we're just basically moving that logic of should you increase bucket B or bucket A and moving it up to the behavior here. So what it is, the robot's mind essentially will look, and then will update accordingly instead of having the update here. So this is a more realistic version, even though it seems a slight difference from what we did last week. So to start doing this configuration file, before we run it and show the example, we're going to build it from scratch, meaning that I'm going to copy in from our configuration file. I have an existing configuration file, and then I'm going to copy it into a blank file what exactly happened. So to help solidify when you're looking at building a cadCAD configuration file is how you can understand what the different parts are and how they fit together. So even though we don't recommend you ever start from a blank canvas with cadCAD, that's just one reason we're providing these tutorials for you and these templates that are on our public repo. So you don't have to start from scratch because cadCAD is set up in a way that there's a framework and you need to run things in a specific order for it to work. But we're going to walk through why it's that way and how to think about it. So when you're looking at just a blank framework, you'll know what each part is doing and better be able to work with it. So as in any Python file, we are going to be importing some libraries. So this is the file, and then I'm going to be copying it to our blank configuration file. So what we have here, we have decimal, which is just so you can handle decimals. This is a standard function in Python. NumPy, which allows for the numeric arrays and vectors and matrices and things like that. Datetime, just so it can integrate each additional day, it can increment. And then cadCAD configuration, these are internal components of cadCAD. This is essentially when we create things like seeds and configurations, the number of runs and things, cadCAD will remember these states to be able to run them. And then these are just additional configuration things, triggers and things of that nature that are under the hood of cadCAD, but will need to be imported into your configuration file. So to start, as we'll just be copying these in, you can now, if you have any additional things you're adding in your configuration files, say if you're doing something with some external library or something, you're reading in some JSON or something, you can import those here as well. But these should always be, this line should always be incorporated into your cadCAD configuration files. So here, we've just started with the introduction here. And then seeds, we don't actually have any seeds here. Seeds, essentially what that would allow is if you have some parts later in your mechanisms or behaviors or things of that nature that you want to have random, but you want to be able to run them, they're random variables, but you want to be able to replicate that exact random number that you generated, you would use a seed. And then these seeds are configured, are appended here, which appended configurations, configs is one of the things we imported as the standard function of cadCAD we talked about a minute ago. So we have to include this seeds dictionary, if not we get an error. So what we're doing here, we're just going to, for sake of this argument, we're going to remove those. I had just commented out random seeds from a different experiment. We don't need those here. And then the sim configuration. This we will always need. This is basically what you're doing is you're telling SimCAD, or cadCAD, sorry. You're saying the number of runs that you want to do. So we're wanting 10 time steps essentially. So after the program runs, then it update. We can see where the policies are, how many balls are in, and how many marbles are in one box, how many are in the other box. But we're going to do that 10 times, 10 different time steps. And this is where in here, that's what T is. N is the number of Monte Carlo runs. Essentially, how many times do we want to run those 10? We can run it multiple times and then average our results to see what's going to most likely happen on an average occasion. Now, this specific example is very discrete. It doesn't have a lot of randomness in it, but when you're doing complex simulations, simulating an economy, an ecosystem, when you're doing the types of modeling that cadCAD is built for, this is going to be very, very important to be able to see 100 runs or whatever, what's most likely going to happen when you incorporate black swans and random events. We don't actually need this here. This is a relatively new feature of cadCAD, which is parameter sweeps. So essentially, if you have a couple variables, say if you have some betas or something like that, some random numbers that are in one of your mathematical functions are not random, but you don't know if you should have 0.1 for a growth curve or 0.8 or somewhere in the middle. You can run it and it will show you the results of everything else held the same, how the model interacts with those different parameters. So we don't need that here, so I'm going to remove that. Oops. And we don't need that in this instance. And here I'm also going to be copying over, just for sake of example, I was bringing more things over here so I can talk through how you'd normally see them, and then I'm removing them when we don't need them in our experiment here. So this, you see the cleanest version of how it would be. The next part along those lines is, this is our time function. So in this case, we're just incrementing. We don't care about time. We're just going to have 10 runs, right? 10 runs of checking the marbles. But in a lot of cases, when we're building an ecosystem, we want to know, are we going to be seeing how off every second or every minute are investors checking the price of your coin, or comparing it, doing arbitrage with it? We can actually, this is a default function of cadCAD, that all you do to change here is you say, are you wanting to do days, minutes, or seconds? And that says what the time increment is. In our model here, we're just like, the time increments. It can be whatever you want. It can be 100 years if you want. We're not going into that level of detail. But in normal cadCAD situations, we would use this. So we are not going to be using that here today. So for this, our blank configuration, I won't even include it. But that is something you always want to use when you're doing a detailed configuration. But we're doing very simple here for sake of example. So next we have, this doesn't necessarily have to be in this order. So these things don't have to be in this order that we have them, but it's a lot more logical how we have it here, as you see when we go to the appended configuration files. This is the order that you need to can append them into this list. So it makes sense to just do them in this way to start just thinking of how this is the logical way we've come up with to run them this way, and then you append them. So behaviors or policies, this is what we've talked about. This is that logic that we had built into the mechanisms last time, which is one step below. So normally when you'd have a behavior, the behavior would be, I'm an investor. When I see the stock price drop, I want to run for the door. And then the mechanism would be selling that stock, and then the state would be how much stock I have left. In this case, the robot arm is being intelligent by seeing how many marbles are in box A and how many marbles are in box B. And this is that same logic essentially that we had last time. So we're just pasting this in here. And then as you see, it returns a dictionary of what the values are for add to A and add to B. You can have two separate numbers here. And then what we have here, this G is the parameter sweep variable if we had that. Step means this is the step. You could have a function that goes, so if you want to say, this is T essentially, you can think of this as T. If you want to raise a power to T or something like that, say if you're wanting to do some kind of a decay function or a growth function, this is last time step, and this is current time step. So as you see here, this is the state, the current state is what the S is, and that's what we try to only use when we're doing modeling, so we don't get too tangled in the other things. We try and just keep, for functioning purposes, just using the state. So it's saying what is the state currently, and then it's taking the example here. So the state you're seeing, you're basically looking at a value. All right, so next we will go to our mechanisms. Our mechanisms are what take the behavior of the state, and we'll see when we link all these together, this will make a little more sense. So the state takes in, as you can see here, input is what it takes in. So it's taking, as you can see, there's add to A and add to B, right? But this is a mechanism only for box A. So it takes the input of whatever A is and adds it to state A. So this is the mechanism that updates that. It's actually moving the arm based off of the policy of seeing what's in each box. So the input here is from the behavior. And as you can see here, the second box is, these are identical functions, just changing the A's to B's. We'll take this part of the policy. So the policy can, the policy or behavior can return a dictionary of multiple values. And you can see the numbers are different here correspondingly. So the final group that we have here is initial states or genesis states that we have. So what this is what do you want to start with? How many marbles do you want in each box to start with? This, you'll have a bunch of different states, and this is what you want to define them as. So, and when we append all of these in the end, they don't have to be in this order. As you'll see, this is the order that's been most logical for us, and we like to stay consistent when we're doing modeling problems, and it'll help you as well if you kind of have an order. For me, it helps when I'm doing behaviors because they influence mechanisms which influence states. So it helps for me to have them in this order as kind of a waterfall of starting from the largest and going to the smallest. So here we're going to have box A, we're going to start with 10 marbles, and we're going to have box B start with 0 marbles. And we can see over time the behavior will tell the different functions to either increase box A or increase box B. So next we have exogenous states. These are the states that you can't control outside of the system. We still have to include all of these components. We still have to include these dictionary parts for the SimCAD model, but we don't have that time model is what I talked about earlier that we deleted. If you want to define what the time is. Since we're not doing that, we don't have anything in here, but the exogenous states are what's taken as a given. They're external to your model. And these are environmental processes. We don't use these that often, but if there's environmental process, we have that here. We're having a blank dictionary here. So we're not using that. And now here's the key component of connecting these behaviors and mechanisms and states. So what we have here, oops. Here we go. So what we have here is the mechanisms and the mechanisms of all of the different components. And then we have the policies, which was this thing we left blank last time. In our last example, there was nothing here. You can run things blank when you don't have a policy. Here we're saying the robot arm is our policy, and that's what we define up here as our behavior. We call them behaviors because that makes more logical sense of what they're doing. cadCAD has them encoded as policies. So that's why I've been using those two terms interchangeably. Behavior makes more sense from a behavioral economic standpoint, and that's why I've been using that term. And then what we have here is the states. So the states are defined here, and then these are the mechanisms that update the states. So you have to have, because the mechanisms here have inputs from the behavior or the policy, it has to be defined here all of this has to be connected in this one thing here. So you can have multiple, then you can have multiple of these policies and things like that. But we have them all. This is how it ties them, as Dr. Zargham likes to call it, wiring up the circuit. This is how we tie these different components together based off our graph we have here. This is how, so we see the behaviors, the mechanisms, and the states, and we have these arrows showing how they interact with each other. Well, that's what we're modeling here essentially, is we're showing, this is the behavior right here, the policy, and then we have the states and the mechanisms that increment those states. So finally, the last part that we have here is the appending all of these different results to our cadCAD internal state. So this is the system here. We're saying our simconfigs, simconfig. We're saying initial state or genesis states are right here. Genesis states or initial states. Our seeds, our exogenous states, our environmental processes. So these on the left hand here, these have to stay the same, and this is what's internal to SimCAD. You can technically name anything you want on this side. You could name mechanisms something else. This is mechanisms. You could name them wires or whatever, and you could say wires and it will still run. But this left-hand side needs to stay. The left of the equal sign needs to stay. So once we finished coding this up, let's run this now. So what I'm going to do is import config blank. So that was what we just did, copied from the config file. And we are going to import this. All of these are additional. So when you're running cadCAD, what you have to have is this tabulate, this cadCAD engine, the executor, importing the configs, and then you need to import your configuration file, and then you need to have this execution mode. And then this thing as well, this whole block is saying, look at the first configuration file. If there's multiples, you want to execute the execution context that we had here, which is here. Basically, it's taking the internal state of SimCAD, taking that policy function, and then being able to do a bunch of computations and spit out the result. And then here we're adding the first result, we're adding it to a pandas data frame for easier manipulation. And then we're just changing the index here so it's easier to see. Then we run that file here. Got to see what happened here. All right, so we imported the config blank here. We're going to run it. And the one thing I noticed right before we ran it, because we removed that, because we didn't need the dictionary sweep right there. I'm removing this comma right here, and that was a little typo I had initially. So now I'm going to come back, and I'm going to import this file. We're going to run it, and we can see the result here. So we start with 10, and then it goes to 8, 6, 4. It will do 2 at each time, and we kind of go back and forth here. A little bit of a yo-yo effect here, as the policies are going from 10 to 8 to 6 to 4 to 2. So then now we're going to have 2 robotic arms here. Let's see, that was what I call, yeah, 2 robotic arms here, where we have, instead of just one policy, we're going to have 2 policies. And then they're each going to look at separate times. So we're going to get another one of these crazy situations here. All right, so we've just run our file here. And we see that because the robot arm is seeing the policy and seeing what it was in the last state, we're moving by 2 here. And it's never quite gets the right equilibrium, because now the behavior is looking and influencing the blocks at the same time. And then so the blocks, we don't actually get to a straight line anymore because we have the interaction going here, which is what we had in last time. So let's quickly go back to show what we had from the last example. And when we look at the last example, when we only had the mechanisms and we had the states, we did not have a behavior, and we had this logic here, we were able to get the same equilibrium here because it would stop when it got to the certain time. So we had our numbers here, and then it would stop. Versus now what we have is it gyrates back and forth because the policy is informing the arms at the same time. So the arms are always going back across each other, and they never get to the complete equilibrium. So hopefully this live coding example was helpful, and we introduced the policy functions this time. And we'll be releasing a request for comments and things like questions that we'll address in a future video, and then we'll continue with part 3 and part 4. Thank you for your time.